Okay, welcome to my presentation. So my name is Dr. Venkatesh K. Bobi, Assistant Professor of Chemistry, Vijayan College, Hospit. Today I'm going to talk on amines. So amines, the syllabus I have to cover in this presentation, that is organic compound of nitrogens, amines, definitions, classification with example of aliphatic and aromatic amines, the method of preparation of primary aliphatic amine, that is methylamine, by alkyl halide, alcohols, Graberly methods, the distinguished test between the primary, secondary and tertiary amine by nitrous acid, the basic character of amine, the comparison of basic characters in the following group of amines, that is methylamine, dimethylamine, triethylamine, B, the aniline, N-methyl aniline, N and dimethyl aniline. So third, C, aniline, paranitro-aniline and paratoluene. The introduction of diazonium salt, preparation and application of the benzene diazonium chloride, diazo-coupling reaction, the reaction of the nitrogen in acid, alkaline and the neutral medium. So this syllabus I have to cover in this presentation. Now move to the amines. Why we need to study the amines? So amines are the organic compound basically extracted derived from the ammonia. So these nitrogen based compound are present in everywhere, like plants as well as the animals in the one or other form. So because of that reason, nitrogen containing compounds are a very important class of organic compound. We need to understand in the better way to know the physiological effect on the human being. So these nitrogen derived compounds are extracted from the plant. The higher plants from the leaf, bark and the root. So where you can easily extract from the plant. That type of the chemistry is called as phytochemistry. So this is the separate branch of chemistry where you can study the isolation, extraction and identification of the nitrogen based molecules. And coming to the synthetic method, so you can synthesize the many amines derivative from the synthetic method. So these are very important because these nitrogen based compound have wide application in the industrial, medicine and pharmacological applications. Due to that, so these nitrogen based molecules are very important to study in the organic chemistry. So these nitrogen based compounds used in the used for the medicine purpose, like the and also sometimes it is also used for the drug, where nicotine is one of the nitrogen based compound where you can find as a drug. Okay, so all this application, so it is very necessary to study the amines. So now coming to the few examples of the amines. Amines, nitrogen based compounds such as methylamine, ethylamine and tetramethyl ammonium and cyclic nitrogen, that is pyrrolidine and the piperidine, and heterocyclic nitrogen, pyridine, aniline and indole, quinine, so on. These are the nitrogen based organic molecules. So what is the definition for the amines? Amines are the class of organic compound which are derived from the ammonia by replacing the one or more hydrogen atom from the ammonia, either by the alkyl or aryl group, are said to be amines. Okay, so I will repeat once again. Amines are the class of organic compound which are derived from the ammonia, where one or two or more hydrogens are replaced with the alkyl or aryl group, are said to be amines. Okay, so this, if you look at the structure of the amines, so this structure is very beautiful if you consider the ammonia. So ammonia containing the nitrogen, hydrogen. Okay, so nitrogen containing the 5 valence electron. Okay, and so in the 5 valence electron, the 3 electrons involved in the covalent bonds and 2 are not involved in the any bond. That kind of the electrons are said to be a lone pair of electron. Already you know that. So due to the lone pair of electron, so molecule we know that this nitrogen is the sp3 hybridized. Okay, so sp3 hybridized means the molecule should be have the tetrahedral geometry. Okay. Instead of the tetrahedral geometry, there is a slight deviation towards the tetrahedral geometry because of the presence of the non-bonding pair of electron. We know that the non-bonding pair of electron occupies the largest space compared to the bonding pair of electron. So there is a strong repulsion between the non-bonding pair of electron and the bonding pair of electron. Due to the occupation of the higher space, the bonding pair of electrons are moved towards the downside. Because of that reason, this the structure of the ammonia is used to pyrimidine shape. Okay, pyramid shape, sorry, it is look like a pyramid shape. So here the bond length is 1.102 angstrom in it. The bond angle is 107. Instead of the 109.5 degree, there is a deviation of 107 degree because of the strong repulsion between the non-bonding pair of electron to bonding pair of electron. This is the one reason. Second reason is that here the nitrogen is bonded to the hydrogens. These hydrogens are very small in size. This occupies a very smaller space. So there is a repulsion between the bonding pair of electron. That bonding pair of electron is very less because the size of the hydrogen is very small. So there is no spherical hindrance. So if at all any spherical hindrance is there, then the bond angle would have increased to higher angle. So here, because of that reason, there is a larger deviation from the 109.5 degree to 107 degree because of the presence of the hydrogen. If you consider the primary, secondary, tertiary amine, the bond angle is increases like anything. So here one of the primary amines are those, one of the hydrogens are replaced with the alkyl aryl group. Here I consider for the convenience sake, I have taken the methyl group. So methyl group is bulky compared to the hydrogen. So there is a strong repulsion between these two bonding pair of electron. Along with that, there is a spherical hindrance between these two atoms. Okay, so because of that reason, the bond angle is increases to 109 degree 18 minutes. So when the two hydrogens are replaced with the methyl group, again the bond angle will again increase to 108 degree 5 minutes. So again the substitute will be replaced. Hydrogen is replaced with the methyl group. So all three hydrogens are replaced with the methyl group. The bond angle will again increase to 109 degree. So it having said that, it is very important to note that whenever the hydrogen atoms are replaced with the alkyl aryl group, there is a increase in the bond angle due to the repulsion between the bonding pair of electron. Larger the size, the larger will be the repulsion. So because we know that all the molecules have to attain the stability at the room temperature. You know, if there is a strong interaction between the two bonding pair of electrons, the stability will be, the energy will be very high. If the energy is very high, the stability will be very less. So in order to attain the more stability, all the molecules will take the space such that they have the minimum repulsion. So because of that reason, the bond angle will goes on increases from the ammonia to your tertiary amines. So this is about the structure of the amines. Now coming to the classification of the amine. So we know that, so already given in the previous slide we have discussed the classification slightly. We go in detail in this slide. The classification of amines are classified into three classes. One is a primary amine, secondary amine, tertiary amine. So these all amines are derived from the ammonia. So the one or two or three hydrogens are replaced with the alkyl amine. On that basis, these amines are classified into three classes: primary, secondary, tertiary amines. Again, you can replace your lone pair of electron also by it forms the quaternary amines. So if you replace the bonding pair of electron, you can get the quaternary amine. This quaternary amine, nitrogen carries the positive charge. Okay. So these are some of the general classification of the primary, secondary, tertiary amine. So again, these amines are further classified into aliphatic and aromatic amines. So we will discuss some of the example for the primary amines. So example for the primary amines are the methylamine is one of the typical example for the primary amines. So CH3 and NH2, one of the hydrogen is replaced with a methyl group. Here ethylamine or butyl 1-amine. Aniline. Aniline also one of primary amine, which are aromatic primary amine. These are aliphatic primary amines. And benzylamine. So this benzylamine again, it is the aromatic amines. Okay, it comes under aromatic amine. CH2 benzyl. This group is called as the benzyl amine. Okay, so secondary amines examples are your N9 dimethylamine, or you can say dimethylamine. This is the diethylamine. So here dimethylamine, this is the amines can be represented in the atomic form or the line and dash form also. Okay, these two are same. So you should not get confused with these two molecules are different. No, these are both are same. Okay, here this is the dimethylamine and this is the N-methyl ethylamine. Okay, and this is the N-methyl aniline. Okay, N-methyl 1-phenyl methyl amine. So these are the few example for the secondary amine. The example for the tertiary amines are trimethylamine, triethylamine, N-ethyl N-methylamine, and N9 dimethyl aniline, N-benzyl, okay, N-ethyl ethylene amine. Okay, ethylene amine. Okay, this is the typical example for triphenylamine. Okay, triphenylamine. Now we will discuss some of the example for the quaternary amines. The quaternary amines are those is derived from the ammonia, where the lone pair of electron is replaced with the covalent bond or alkyl or aryl compound are said to be quaternary amine. This quaternary amine have the nitrogen carries the positive charge. So some of the example is tetramethyl. Tetramethyl means 4 methyl groups are directly bonded to the nitrogen. So therefore tetramethyl ammonium. Ammonium means it is a cation. Again tetraethyl ammonium. So here N means the aliphatic group are directly bonded to the nitrogen. In that case, they will represent with N triethyl. Ethyl groups are directly bonded to the nitrogen. How many ethyls? 3. Therefore, 3N is given. NN triethyl benzylamine. So these are the few examples for the amines. So I will revise once again. Till now we studied what are the amines, why we need to study the amines. So because it have the very wide application in the industrial, pharmaceutical and the academic purpose, it is very important to study. And third point, the structure of the amine. Here the structure of the amines are not a tetrahedral geometry, because nitrogen is the sp3 hybridized. Even though it is a sp3 hybridized, it is not a tetrahedral geometry. It gives the pyramidal shape, because there is a presence of the lone pair of electron that makes the geometry change to tetrahedral to pyramidal shape. And coming to the classification, the amines are classified into 3 classes: primary, secondary, tertiary amine. And in turn, again, it is classified into aliphatic amine and the aromatic amine. Next class, we are going to study the physical and chemical properties and preparation of the amines. Thank you.